All right, I guess we're about to get started. I'd like to welcome everybody out. My name is Brandon Poole. I'm going to be presenting Detectors as Code, Building Better Detections. So who am I? So my name is Brandon Poole. I work with Soteria. I'm a detection engineer. That's my official title. However, really and truly, I guess I'm more like a person who does a lot. Probably like my biggest bullet point. My job description is other tasks as necessary. But yes, I've been with Soteria for a while. My role as a detection engineer is in the Dart. So what I do kind of in the Dart is it is my job to go through and build detections in order to detect advanced adversaries. So we do this by a number of means, signature-based rules, behavior-based rules, and really try to build out like a solid product. And this is kind of where this talk actually came from, is some of the methodologies we've actually implemented. So in the beginning, man created the code and the task was tedious and error-prone, and no one liked it. And then man said, let me automate it, and he automated it. This really and truly is the whole power of computing. And if you think about it, this kind of happened with the way we do security. But first, let's talk a little bit about the history of Infosec and detection. So back in 1972, there was a paper published by James P. Anderson. He was a general in the Air Force, or a lieutenant in the Air Force. And the paper noted there were a growing number of security issues. They noticed more and more kind of like viruses, weaknesses with systems. The resiliency wasn't really there. So he documented this stuff and said that, he really saw like cybersecurity becoming an issue here in the future. He followed up with a theory about automating intrusion detections in 1980s in another paper. That paper ultimately led to the first intrusion detection system being created in 1984 by Dorothy Denning and Peter Newman. This isn't the IDS that we know today. This was actually what they call like an intrusion detection expert system. This was a precursor to the AI, deep learning, and everything that we heard now. Like a lot of the marketing we see now, it didn't have a whole lot of potential. And so ultimately it kind of fell apart, but this was really the first intrusion detection system. What they tried to do is they tried to take what an analyst would look for, weight these things out, and try to mimic actually how a human would think about things in order to detect these malicious events. Like I said, it wasn't really all that successful. They continued to kind of tinker it and kind of work out all the technology. Then in 1987, the first antivirus was released, and then we kind of had like a nice detection kind of like winter, I guess you could say, until like 1999 when eSecurity released the first SIM. A few years later, they were snapped up by Novell. And then in the mid-2000s, the first EDR, Carbon Black, came onto the market. And if you think about it, all these tools, in a way, require detections to be made. And these detections that we kind of make, if you think about it, are code really in and of itself. Your EDR tool is like an interpreter of sorts, or a compiler. You write a rule for it, it interprets it, compiles it, and does what it needs to with it. It might not be a Turing-complete language, but same thing really with your IDS. You're writing some type of code, you can view your IDS system kind of as a compiler or interpreter, and you're passing it, and it's executing some kind of like functionality. So when you think about it, we've actually been doing kind of like this detector as code stuff for kind of a while. So yeah, I mean to tell you, pretty much already been doing detectors of code. Kind of surprising, right? Yep.
Yeah, it is.
Thanks for coming to talk. Nah, just kidding. So there's a lot of problems with our current detector strategy. Yeah, we're doing it as code, but the thing is that we have like a ton of issues still. Like these are actual quotes that I've heard during my time as like a security person. Like, hey Brandon, you know that rule I just made? Completely blew up the SIM. Like 20,000 alerts in like 5 minutes. Probably want to clear that out. It's not really something you want to go through as an analyst to try to clear out like 20,000 alerts, especially when these types of rules often create like a backlog effect. So you kill the alert and you continue to still get like another 20,000 alerts over the next 2 or 3 minutes. Another thing that I've actually heard is, you guys noticed we haven't got any IDS alerts since we upgraded the IDS appliance 6 months ago? Oh, should have caught that one. Or, you know that EDR rule that I created to detect if we got pwned again? Yeah, I didn't really quite test that rule logic the way I should have, and by the way, the guys are still evidently in the network and on about like 20 or 30 assets. Not something not really a talk you want to have with your C-suite. And probably the most disappointing one is, you know that noisy rule I tried to tune out? I broke it. You don't happen to remember what the old rule logic was, where do you? I didn't write it down, and it'd be nice to somehow or another get it back. I mean, really and truly, like the way that we implement detections as a whole is just completely and totally broken. And we kind of realized that here at Soteria when we went into it. We really wanted to solve this problem. And there's a couple other organizations that's also kind of thought about this problem. And this talk really is about our solution here. So, I mean, let's really touch on, like, you know, I gave you a nice bunch of quotes, but let's really touch on what the problems are. Are your detectors reliable? If I upgrade an operating system, are you sure it's still going to work? Are you sure that some part of that EDR system is not going to break? Are you sure that that IDS is still going to function the same way? Those IDS logs and alerts, they're going to still have the same fields that you can parse? Are my detectors resilient? If I make a detector that looks for Mimi cats somewhere in there, and I change it to Mimi dogs, is it still going to fire? Do I provide all the coverage I need with my plethora of detections in order to make sure that my organization is secure? And as we've kind of harped on, are my detectors bug-free? The answer to that question will always be no. That's essentially what false positives are. That's essentially what false negatives are. False positives overwhelm analysts. When they're overwhelmed, they kind of get into this routine like, it's always been a false positive, going to kind of ignore it. The false negative issue is you can't fix what you don't know. So if someone's in there and it's a false negative and it never fires, I mean, that's essentially a bug. You want perfection, but unfortunately, like just about any other software product out there, there's no such thing as perfection. The solution to the bug you currently have in place is just ultimately going to cause the next bug you have to fix. But that being said, there's always an acceptable number of bugs that you can push into production, you can really just handle. So really, the ultimate question is, does your detectors work as expected? Yep. You can see the panic on some people's faces. Not really. But it's kind of a scary thing. It's really kind of a dark thing if you think about it. Like the tools and technology, even if you're not writing your own detectors, if you're using a Palo Alto and you're using that IDS function built into it, the IPS function built into it, do you know that it's doing what it's supposed to do? It's kind of scary. I mean, you pretty much are putting all of your eggs in one basket. We got a solution to that. DevOps. The reason it's a solution is because it's a really cool buzzword. And to be honest, it actually works. So, you know, we kind of talked about like detectors as code, like what actually is like detectors as code. Well, what if, you know, if you think about it, software developers solve these problems, these bug problems, these resiliency problems. Does my code work the way I expect it to work? And really and truly, if you think about it, there's no reason to reinvent the wheel. We can just take from their 30, 40 years of practices of develop like an actual life cycle for this type of stuff. We can adopt it and we can apply it to our own code, as you will, our detectors, and use the same strategy. Now, DevOps is kind of like one of these newer coding strategies. It'd be probably pretty helpful to break it down for those who are unfamiliar in the room. So really and truly, like DevOps as its core is like a set of software development practices that really and truly what you're trying to do is you're trying to bring that dev part and the operation part together. The problem is there's usually like a disconnect between the people developing the rules and the people that's maintaining the appliances. They don't get along, they point fingers, they don't work together tightly enough, and because they don't work together tightly enough, there's communication problems, all these things that seep in. That's ultimately what causes a lot of the issues you see in production. So the kind of idea behind DevOps is to kind of merge those almost into like one type of organization. They have like very specified communication channels. Developers are trained in operations. Operation folks like understand development, so they both understand each side of the equation. They help each other out. It's kind of like it's not too novel if you think about it, but it's really been kind of like earth-shattering in the way we do things. Also, a big function of DevOps is really trying to minimize what we call WIP, work in progress. The idea is if you as a company are paying for $10 million for some software application to be developed, you don't want to wait 3 or 4 years for that $10 million to be realized. They would much rather shorten that work in progress cycle and get something out that maybe isn't as feature rich, but to get it out in production so they have something so they can start earning back some of that technical debt they've accrued, to like start making a dent and like justifying this $10 million investment. And DevOps really helps out for this because first of all, having really the operation folks, the IT folks, and the developers kind of on the same page, understanding stuff, communicating better, really understanding the technology stack. I mean, that's one thing to kind of push that out. But there's a whole different piece to that, and that's where the continuous integration and continuous development pipelines come in. The idea is that, way back in the early 90s, even mid 2000s, a lot of the testing that we do for software to make sure that there's a user acceptance test. Are there going to be as few bugs as possible that users aren't going to just rage quit? That was all done manually. And eventually developers kind of wised up and decided we can automate these tests. I mean, a lot of these are very simple tests. We already kind of automate unit testing, so we can probably automate user acceptance testing, regression testing, all these things. And really and truly, this is how we kind of come up with continuous integration and continuous deployment. Continuous integration is that idea of going through and pushing pieces of code as quickly as possible that actually function. Get them out there so they can be used. That continuous deployment is kind of like that piece that's actually doing the testing. So what happens is as you deploy code, the code is automatically tested. If it passed the test, it moves to the next stage. So from the dev environment to the QA environment. Maybe in the QA environment, there's some different tests that are done. Maybe you're testing for scalability and not the code in QA. If it passes those scalability tests, that stress test, then it moves over to prod automatically. And really and truly, if you think about it, we'll touch a little bit more on this. Change control is kind of already built into this tooling and technology. So that's one of the ways you can automate it, because that change control process that's usually a foundational piece is actually built in. And it's very easy to revert back bad code that you thought was acceptable, maybe made to production that you didn't have a test for. It's really easy to kind of move that back, especially with the use of source code management tools like GitHub, GitLab, because I actually have version control built in. If something doesn't work, I click back, it reverts, goes right back through that same CI/CD pipeline, and then boom, right back to the same state I was before I pushed that bad code. So if you really think about it, our solution, or what we're defining as Detectors as code, is really adopting this strategy. Storing the detector logic in some type of software management code repository like GitHub or GitLab, or even Bitbucket, or really anything out there that most of your software developers use. Building a CI/CD pipeline to run automated tests against this detector logic, and deploying the detector logic. If it passes all the tests automatically, no human interaction involved whatsoever. But it is important to notice that this is not DevSecOps. We're not going to touch on that. I'm not going to try to teach you like a whole crash course on DevOps here. So this is not what that is. That's the process of actually building security into these pipelines. We're not going to touch on that, so please don't confuse this with that. So the benefits, we've kind of already touched on them, but let's really kind of like hone in on them. Change controls built in as a core feature. I put in code and I check it into the repository. For it to go to the staging or master branch, which is like another place that the code is moved to, it has to be peer reviewed. So like my peer David sitting up here in the front would look over and says, yeah, this looks like it's pretty solid. It meets our standards. I'm going to approve it, and it gets approved. And you can have 2, 3, 4, however many steps of peer approval you want in there. And once it meets all that peer approval, you can even break it up at the front, at the end, throughout the whole process. And as it goes through, that's almost like your change control. It's audited right there into your source control management system. The version control is a core feature of these source control management systems. Reverting back to old code, that whole like, oh, forgot the sim logic. You guys remember what it is? Easy, just button click right back. We can also improve detector resiliency through automated testing. So frameworks like the Atomic Red Team, Caldera by MITRE, all this stuff you can actually build into this CI/CD pipeline, test this stuff, and you know exactly if your rules are going to fire the way you expect them to fire. And the big thing is we're reducing the time to deploy detectors this way. I'm not having to wait to go through like some long, rigorous like change management thing where some SOCs, in order to keep the SIM from breaking, it's like, all right, well, we're going to deploy all of our rules Wednesday at 9 a.m. If a threat comes in on Thursday, you write a rule. I mean, I don't think your threat actor is going to wait till next Wednesday to like breach your company. I mean, if they do, that's really nice of them. I want to have your problems, to be honest. But you don't have to worry about stuff like this anymore. You don't have to worry about going through a process that's going to slow you down and that lack of visibility because that process of getting new stuff deployed is so slow. So let's talk about the process overview here. So this here is kind of the process that we've developed. And I'm going to touch on a couple of different things here. And kind of some customizations and tweaks you can do. So as you can see, kind of like our stage one is new detectors are really submitted to our source control management platform. But who are like building these detectors? Well, primarily our detection engineers. But the thing is, like, our detection engineers don't necessarily know everything. So what we've done is using the source control management system, there's an issue tracker in there, usually used for tracking bugs. What we actually do is we open up to the whole company. So our detection engineers can say, hey, I read this blog article, or while I was working, this alert, I noticed that there was this other activity that didn't fire. We should make a detector for it. Our threat intelligence team, we got some threat intel through some sharing programs. This threat actor is using this method. I don't know if we have coverage or not, but I'm going to put it in there and open up an issue. Malware reverse engineers, if you're lucky enough to have them, maybe they break down a new way that malware is executing or maybe escalating privileges on an endpoint. They can put in and say, hey, notice this new unique way they're escalating privilege, this new banking Trojan. Put it in there. Incident responders, I mean, those are guys boots on the ground. They see something and they're concerned that we don't have coverage. They can put in a request. Security analysts, really anything. Like we even open it up to like C-suite. I mean, I don't know if the C-suite is going to put a detector in, but I mean, hey, if they have an idea, they're usually just in the know because it's their business to know about the risk to the company. They can put an issue in. And our detection engineers take it. They kind of build that kind of detectors from those issues. Now, the question is, how do you build this? Like, your SIM's not going to use the same language as your IDS. Like, QRadar doesn't take the same rule logic that Suricata does. Suricata doesn't take the same rule logic that a Bro does. Bro's not going to take the same rule logic that a Carbon Black would. So really and truly what we've done is we've developed like a YAML file. YAML's really, really simple. We'll take a look at it here in a minute. But what we're able to do is we're able to put that code logic for each platform in a YAML file, able to say what platform it specifies to. You're even able, if you want, to build out an actual playbook for how to handle that in this YAML file. And you can actually use this YAML file as like a playbook, kind of like your one-stop shop for everything you need to know about this detector. And you can push this YAML file through your CI/CD pipeline. So we use Jenkins, which is a traditional developer tool. Jenkins is very nice. It's open source. It's free. There's plenty of training out there on like Pluralsight or just about any of your training platforms. You can go buy books on it. But there's other ones out there too. Circle CI is kind of like a cloud one built natively into GitHub. So is Travis CI. To be completely and totally honest, a lot of the stuff that we're talking about doing, if you have a SOAR platform like Demisto or Phantom, they have connectors right into GitHub. You don't have to go and try to figure out Jenkins and learn Jenkins and stuff like that. You can just use the plugins built right into Demisto, right into Phantom. You don't even need to pay for it. You can actually use the free version and just do the same thing because they have the API integrations into your SIM to push new rules and update rules. So, I mean, it's really that simple. Like, you don't need to have necessarily a full-time dev on your staff to implement this kind of stuff. Now, one of the things you can do is, you want to have some environment to kind of test this in. You can use Terraform to like build up a environment. Now, what's interesting, and this is kind of the whole reason we jumped on this kind of like thought process for this, is Terraform is infrastructure as code. This here is something that, everyone thought had to be like a wrench-turning process, hands-on, there's no way you can automate it. And pretty much like HashiCorp came out with Terraform and proved that you can actually just codify all your infrastructure, all your configurations, and set it up on the fly and tear it down. And that was also one of the reasons that we really thought that this model would apply to our detections as code. So I can build an environment from scratch, test in it, push it through, bada bing, bada boom. And once my environment's set up, now I can use kind of like my own internal tests. I can use MITRE's Caldera, Atomic Red Team, really and truly like any of these frameworks that are designed to kind of test your security. Attack IQ, if you want to go on the paid side. There's a lot of frameworks out there that you can really kind of use to test your detections. And really kind of like step 6 is all the stuff gets fed back into Jenkins. If it passes the testing phase, Jenkins will go through and like tear down that whole Terraform architecture, and then it'll push it out based off the YAML file, and it'll push it out to your EDR sensor, whatever it is, your network security platform, so Suricata, Snort, Security Onion, Zeek, formerly known as Bro, your SIM, and you're pretty much up and running, just like that. Yeah, I know there's a lot to take in. So we're going to break it down a little bit further. So phase 1, we kind of touched on it, is a new detector submission. So the way we decided to do it is we are a very use case driven organization. We don't want to make just detectors for the sheer reason of having detectors. And so when a C-suite person comes up, they're like, do I have coverage for this? And you're like, oh yeah, sure, we have like coverage for this. I'm sure we got like 20,000 rules. And only come to find out like it's the same 20,000 rules covering the same thing. So we build out use cases. What do we care about? What do we want to detect? So, the folks put in these issue things, and what we do is we ask them to put in kind of like a summary here that you can see on the screen. So summarize kind of what I'm looking for. The threat model. Why am I actually concerned about making this rule? We've got some additional details here. So we like to map our like stuff over to MITRE so we can actually map out what the coverage is. ARC test exists, so that's Atomic Red Team. So is there an Atomic Red Team test that I can already utilize, or am I going to have to build my own test? There are any additional notes. If I want to learn more about this, what references did you use to come up with it? So I can kind of build out this whole template. And the nicest thing is if you're using something like a GitHub or GitLab, you can build these templates automatically. So when someone goes and clicks new issue, it's just a blank template there, and they have the summary, threat model, additional details, and they just have to kind of like fill it out. Another thing is over here, kind of on the right-hand side, you can see what we call labels. So labels are kind of like a tag. So we can apply these tags to it. So I can apply, does this rule work for Windows? Does it work for Mac? So I can talk about the OS it applies to. Is it a network layer type of detection? Or is it more of a host base or an application base? I can tag it whether or not like a test exists already for it. I can test if it's in MITRE's attack framework. A lot of people think that MITRE attack framework is comprehensive. It's not really. It's a work in progress. it makes it for like very, very, very easy kind of like organization, categorization, and it really helps us kind of break down, like if you have like customer coming in and say, I'm in a Mac environment, are you really going to be able to help us? I can pretty much use these issues on what's closed, because if the issue is closed, we've actually developed it and pushed it into prod. And I can go through and say, yeah, we have like, 20 detections for Mac, which, might be pretty on the low side there. But just throwing something out there, 20 detections for Mac, and it covers like these 7 different use cases, these MITRE techniques, and I can give you details just based off this issue tracker. And then the nice thing is most of these source control management systems, you can kind of group a lot of these issues together in what we call milestones. So it gives you a way to kind of manage these as like a project. So I can actually go and say, this week I want to work on like these 20 detectors. Joe's going to take these 5, Jill's going to take these 5, and you can kind of break it up and then measure progress. Oh no, locked up there. Yeah. Hang with me here just a second. So everybody knows IT in the room? Any IT folks? Technology folks? Let's try this again. There we go. All right, so phase 2, where we're actually developing the detector. So we're taking these issues now, and we're actually trying to make something of them. So this kind of goes into that YAML format that we were talking about. So there's a couple fields we usually require in a YAML, and we kind of recommend everyone do. One's a universally unique identifier. So this kind of helps, makes it easy for us to count the number of detections we have. It also makes sure that, the detector is not going to be overlapping in name, and it's like actual, like a separate detection altogether. The other thing is like, UUIDs are great. Kind of like IP addresses though, they're hard to memorize, and if I say, alert 86 fired, you know what that is? I don't. So you really wanted to have kind of a detector name or some way to actually understand what's actually firing. So this is kind of our human, kind of like readable. It's like our DNS name for these rules. So we're popping that in there. And that's what we're kind of like pushing to the IDS or the SIM that we can actually read. So status. So this is another thing. Like maybe you write like this really good rule. You think it's a really good rule at the time. You go through and you deploy it. And let's say it's not as good as what you thought it was. Maybe you don't need it anymore because you realize you already had overlapping detection. You can have a status field. So I can have a status field as active. So it's actually going to deploy to prod. Archive, if I realize it's no good anymore, and I don't have to delete it. So I can still say, hey, we tried this rule at one point in time and it didn't work, or for some reason we've archived it. You can even do something like a testing. So let's say that, you're just not into all this new age DevOps stuff. Just, I deployed to prod. You still want to keep some of that old school kind of mentality there. You can put it like a testing tab and deploy it to like testing systems. Or maybe like, you just want to push to some non-critical assets like IDSs on some parts of the network you don't really care. You want to kind of get a better feel for the performance impact. And really like the last one that you need, and kind of the essential thing, is that detection logic. So what is the thing that's going to go into the SIM that's actually going to compute and do the hard work? What is the actual IDS rule that we're going to push the snort? You can just store all that in the YAML field too. Now there's plenty of other things you can put in these YAML fields. They are great ideas. Playbooks. So once again, like, you've got like a URL reference in your snort rule that says, hey, go to this URL for more information. Think about it. You can put the URL to that detector logic in GitHub. So when it fires, you click that link, it takes you to the GitHub page. You can see the rule logic. You can see who created it, when, the UUID. You can pop a playbook into that YAML file. It wouldn't get pushed necessarily to your IDS, but it's right there. So you can read about like the playbook. You can read about known false positives, how to kind of work this stuff. So really and truly, this becomes like your kind of like knowledge base at this point in time if you want to do it that way. Really, the world is your oyster. YAML, you can put whatever you want in there. It's almost like a JSON, but it's a lot easier to read than a JSON. Phase 3 is that automated testing. We're going to spin up that infrastructure with Terraform, Once again, if you don't want to be all new agey and you don't feel comfortable with Terraform, you can just use physical hardware VMs that are persistent. Deploy to them. In your YAML file, you'll specify like the test to run against it. So Jenkins knows what kind of test to actually run against it. They'll deploy the rule to that EDR sensor on that box, that, IDS sensor here on the segment of the network. Even for IDS stuff, you don't even have to deploy it to an actual real IDS sensor. You can deploy it to a VM you just spun up, use TCP replay, have like some packet captures you want to replay against it, replay it, and if it generates the alerts you expect it, move on. Now, we kind of touched on it before. There's a lot of these like frameworks out there that are for free. So Atomic Red Team's a big one. There's a whole community around this. MITRE's Caldera, we still have on there. They've actually just recently moved over to utilizing the Atomic Red Team detections and kind of methodology. In-game's Red Team automation. Uber's got one, but the name kind of evades me here. But there's also paid solutions. I mean, you've got Threat Care, you've got Attack IQ, you've got all these solutions you can use too, the simple button clicks. And to be honest with you, I'd recommend you probably using kind of a combination of all these, plus maybe even building your own. Atomic Red Team are going to test or built a certain way to test a certain technique. In-game's Red Team automation is built another way. So the thing is, your rule could fire on Atomic Red Team, maybe it wouldn't fire for the test that in-game's Red Team automation framework has. So maybe you can look at kind of mixing and intermingling the two to get your coverage up. Really and truly what it boils down to is you really need like good internal testing techniques. I mean, does that detection logic actually detect the intended behavior? Does the detection logic detect any unintended behavior? Are you generating too much false positives? Like I said, you're always going to have false positives. The question is the number of false positives that you are creating, is it acceptable to the number of staff that you have? And are you willing to accept the risk of minimizing those false positives and possibly introducing that false negative? Are my detectors resilient enough to withstand common invasion techniques? If I change Mimi cats to Mimi dogs, is it still going to work? I can build that into like a test really quick, really easily. If I know I'm going to upgrade my IDS sensor, I can upgrade the IDS sensor with Terraform, deploy the codes there, have packet captures of known bad, replay it, and see if the new version's not going to break something. So I can determine whether or not I'd actually need to or want to upgrade those sensors. Or if I need to wait a little bit and possibly reevaluate the way I'm doing my detections. Or maybe reach out and put in a bug request. Phase 4, this is pretty much where like the gold is, if you ask me. It's that automated testing, or automatic deployment. So over here, kind of at the top, you can see we have our YAML file that's stored in Git. We have some of the fields that we talked about. So we have like a UUID. Our UUID for this one is LEAP. I thought I was going to get more laughs than that. But the status is active. In this case, we're actually looking for MSHTA executing on a URL. You can see here, kind of like our detector, we stated the detection platform is the Lima Charlie EDR. And our detector code is just, kind of a dummy field at this point in time. But that's going to go to Jenkins. Jenkins is going to go and check and say, is the detector active? Yep. Deploy it to my Terraform infrastructure. Run my test. Did it pass all the tests? Yep. Deploy the detector logic to the detector platform, which in this case is Lima Charlie EDR. You're up and running. That simple. Now, let's talk about like tying this all together. Really and truly, if you take this image right here and you compare it to the software design lifecycle, it's almost a perfect overlap at this point in time. We are identifying our issues, whether that be for a tuning request. It doesn't have to be a new detector. You can put an issue in for a tuning request. A coverage gap, a new technique. I'm identifying this stuff. I'm writing it up. I'm doing my planning. Then what I'm doing is for my planning, I'm actually going through and I'm building it. I'm researching it. I'm developing the YAML. I'm determining what is the acceptable false positive and false negative rate that I'm willing to accept for my testing. Then I'm pushing it off and I'm performing my testing. the tests are ran against my new detectors. We see if they do what we expect them to do. And you can really, like I said, touched on earlier, you can do all kind of testing. You can do pretty much like your resiliency test. You can push it to sensors and you can like just stress test it to the core and see if it's going to affect like how that endpoint for the EDR tool like really runs. There's so much you can do there. And then ultimately the last stage is actually deploying it to production. I mean, that's the most important part. If it's not in production, I mean, who really cares? The thing is that with this this kind of like DevOps detection as code model, we're pushing them straight to production in an automated fashion when they pass the test, when the proper reviews have been done, and then we're able to kind of like monitor it after it's done there, and we're kind of able to like metric that false positive, that true positive rate, see if how it performs in production is the way we expect it to. And if not, that kind of gives us ideas of things to go back and build new tests for this detector and others. And then ultimately, like I said, at some point in time, like you deploy a new technology or something like that, it's probably going to create a lot of false positives. You got to go back, retune it, start the whole process over again. All right, so questions, concerns, comments, any of the above? All right, seeing none, I'll stick around, so if you have any or you want to talk. Another thing to note, we are hiring, looking for interns, so if any of you guys are out there looking for full-time jobs or internships maybe next semester, let us know. Part of the reasons we couldn't really do a demo today is because we sacrificed all the other interns to the demos gods for the presentation we did a while ago. So like I said, we're always looking for new interns to sacrifice to the demo gods. So yeah, but thank you for coming out.